Okay, Wildcats. Today we're looking at Friday, May 10th, trigonometry ratios on page 83. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. Trigonometry sides and angles on page 83. Finding side lengths of triangles. Step 1, choose which trig ratio to use. Step 2, substitute into the trig ratio. Step 3, solve to find the side length. Okay, finding angle measures of triangles. Step 1, choose which trig ratio to use. Step 2, substitute into the trig ratio. Step 3, solve for the angle using inverse ratios. All right, now your notes are updated. Let's take a look at our examples. Example 1, find the measure of each side indicated, round to the nearest tenth. Okay, so it looks like, let's write down sa, ka, toa. Okay, now it looks like here we have, based on 37 degrees, we have the adjacent and the hypotenuse, so we're going to use cosine. So cosine of 37 degrees is equal to 11 divided by x. Now we cross multiply, so we get x times cosine of 37 degrees equals 11. We divide both sides by cosine of 37 degrees, so x equals 11 divided by cosine of 37 degrees. Okay, so let's put that in our calculator. So new document, no, add calculator. So we're going to press Control divide, 11 divided by cosine. Now to put cosine in, there's a trig button, which is right there next to the equal sign. Press that. Cosine of 37. Now, you might think, oh, that's the correct answer, but you need to check something. So we're going to go to On, Settings, Settings, Document Settings. Now, notice it says rating right there. That means it put 37 radians. We don't want that. So we're going to go change that to degree and make default. Press OK. Now go back to current, and I'm going to highlight enter, and the answer is actually 13.8 because that put in when you say it's 37 radians. This is now saying 37 degrees. So your answer is 13.8. So you know, make sure your calculator is in degree mode. Okay, so that's 13.8. All right, let's take a look at example 2. Now example 2 looks like here we have opposite and adjacent, so we're going to use toa or tangent. So tangent of 32 degrees is equal to x divided by 13. Right, cross multiply, so then remember this is divided by 1, so 1 times x is x, and that's 13 times tangent of 32 degrees. All right, so let's put that in our calculator. So trig, tangent, oh, almost forgot, 13 times tangent of 32 degrees, which is 8.1. Okay, example 3. So it looks like here we have opposite over hypotenuse, so we're going to use so or sine, so that's sine of 37 degrees is equal to opposite over hypotenuse, so x divided by 10.3. We cross multiply, so then x equals 10.3 10.3 times sine of 37 degrees. So let's put that in our calculator. So 10.3 trig button sine of 37 is 6.2. Okay. All right, go ahead and finish up those examples. All right, let's take a look at example 4. Find the measure of each angle indicated, round to the nearest tenth. Okay. So it looks like we have the adjacent hypotenuse, so we're going to use cosine. So cosine of theta is equal to adjacent divided by hypotenuse, so 12 divided by 13. Now, what we need to do is multiply both sides by the cosine inverse All right, and to understand why, let me just pick a random angle to show you what happens over here, okay? So if I do trig cosine inverse of trig cosine, let's just pick a random angle, say 50. So you can see here that the cosine inverse and cosine cancel and you're left with 50. So that's the same thing happens here. Cosine inverse and cosine cancel and you're left with just theta. Now, all we need to do is put trig cosine inverse of 12 divided by 13. And so the angle is 22.6 degrees. And you want to make sure if it's a degree, you put the degree symbol. All right, example 5. Now here it looks like we have opposite over adjacent. So we're going to use tangent. So tangent of theta is equivalent to 4 divided by 13. And then we're going to take tangent inverse of both sides. So we know that cancels. And then we just need to put tangent inverse of 4 divided by 13 in our calculator. So trig tangent inverse of 4 divided by 13 is 17.1 degrees. All right, let's take a look at example 6. All right, it looks like we have adjacent over hypotenuse. So we know it's hypotenuse because the hypotenuse is always across from the 9 degrees, okay? So we're using cosine. So cosine of theta equals adjacent, which is 6 divided by 9. Now we do cosine inverse of both sides. So cancels, and then all you have to do is put cosine inverse into your calculator. So trig cosine inverse of 6 divided by 9 is 48.2 degrees. Okay, let's take a look at example 7. So it looks like we have adjacent and opposite. So we're using tangent. So tangent of theta is equal to opposite, which is 11.9 divided by 10, and then take tangent inverse of both sides. And to be consistent, I've been using capital T's this whole time, so let me use capital T. So tangent inverse of tangent of theta and tangent inverse of 11.9 divided by 10. Well, again, we know that those cancel, left with theta. So trig tangent inverse of 11.9 divided by 10 is 49.5, which, or actually 49.9, which lets us round that to 50 degrees. All right, go ahead and finish up example 4, 5, 6, and 7. All right, now let's take a look at example 8. Solve each triangle, round answers to the nearest tenth. So here, we want to find all of the pieces that we're missing. Okay, so let's first find the degree. Okay, now we know that angle A, well, a triangle adds up to be 180 degrees. Well, that's 90 of it, so these two angles add up to be 90 degrees. So to find angle A, we're going to take 90 degrees minus 62 degrees. So angle A is 18 degrees. Okay. Now, so we have that piece. Now we need to find BA and BC. So let's start with BA. Okay. So to find BA, we know that that's the hypotenuse. It's across from 90. So we have the, with respect to 18 degrees, this would be adjacent over hypotenuse. Okay. So that would be cosine. So cosine of 22.6 degrees. Oh, what am I doing? Not that. So I want to be careful when you work. That's cosine of 18 degrees. Let's go to the adjacent, which is 22.6, divided by BA. Okay, so cross multiply, so that's BA times cosine of 18 degrees is equal to 22.6. Divide both sides by cosine of 18. So BA equals 22.6 divided by cosine of 18 degrees. Okay, so let's put that in our calculator. So then that's control divide 22.6 divided by trig cosine of 18 degrees, which is 23.8. Okay. Now, the last piece, we can use Pythagorean theorem to find BC. So BC squared plus 22.6 squared equals 23.8 squared. So we can subtract 22.6, so BC squared equals 23.8 squared minus 22.6 squared. Take the square root of both sides, so BC is equal to the square root of 23.8 squared minus 22.6 squared. So let's put that in our calculator. So control square root of 23.8 squared minus 22.6 squared is 7.5. Okay, so 7.5. All right, so those are all of the pieces of the triangle. If you would, go ahead and finish your examples and start working on an assignment, and have a wonderful Wildcat day.